welcome back to section 8.3, page 2. Here we're being asked to find the area of a square. In the first case, we're told the perimeter. So we know that to find the area of a square, we need to multiply the sides together, base times height. But we don't know the side, so we have to find the side. So let's go ahead and draw a picture of a square. Okay, and since we don't know the side, let's call it x. And since a square has all four sides the same, we'll call all four sides x. Okay, well, we do know that the perimeter is 14.8. And the formula for perimeter of any shape is add all the sides. Okay, so we know that the numerical value is 14.8. And when we look at our picture, we know adding all sides means x plus x plus x plus x. Or 14.8 equals 4x. So to solve for x, we need to divide both sides by 4. And then what does that give us? So we can use our calculator here to come up with 14.8 divided by 4 gives us 3.7. All right, so now we know the side of the square is 3.7. So to find the area, that's simple enough. It's equal to base times height, or area would equal 3.7 times 3.7. All right, so what would the area be equal to? Well, let's figure that out. When we multiply that on our calculators, we get 13.69. Now, what are the units here? We know since it's area, they have to be square, and square what? Centimeters. And that's the answer there. Okay, on to this new problem here. Now we're told we have a square, and it has a radius of length 4 square root 2. So let's go ahead and draw that picture right here. To make it look like a square. Okay, there's our square. Now, a radius, we have to remember, how do we do that? Well, we start in the center, and where do we draw it to? Not straight down, that's the apothem, but rather to the vertex. That is equal to 4 square root 2. Okay, that's what we know, inches, but we'll deal with that later. All right, well, what formulas do we have here? Since we're in a square, we know that the area, or we know that the diagonals, this is half of a diagonal, the diagonals are perpendicular, which allows us to use the formula area equals 1/2 d sub 1 d sub 2. Okay, that's going to be our shortcut. Well, all we have to do is extend this a little further and we have the diagonal. Now, we know that the radii would have to be the same, so this is a radius, well, so is that. It goes from the center to the vertex. So this is going to also be 4 square root 2. All right, so that's one diagonal. Well, what does that end up being when we add that together? Well, we'll call this diagonal 1. Okay, so that's diagonal 1. So diagonal 1 is equal to 4 square root 2 plus 4 square root 2, right? Okay, so I know some of you haven't had a lot of practice with radicals, but if we just think of it being 4x plus 4x, wouldn't you say 8x? Well, the x is just in place of the square root 2. So what we have here is 8 square root 2. That's the first diagonal. Okay, so when we put in the formula, we would say 1/2 8 square root 2. Okay, so then what would the second diagonal be? Well, aren't the diagonals of a square congruent? They are. So we're going to say since diagonals of a square are congruent, we know that d sub 2 is also equal to 8 square root 2. So we can put that in for this one. All right, so what do we have here? We have 1/2. Then I'm going to reorganize. Everything's multiplied, so I'm going to put the 8's together, and then I'm going to put the square root of 2's together. So we get 1/2. 8 times 8 is 64. Square root of 2 times square root of 2 would be the square root of 4. And the square root of 4 is 2. Now you can multiply any order you want here. You can say 1/2 and 2 cancel out, or you can multiply this first, whatever, however you want to do it. But in the end, you should get 64, okay? So that's our final answer. Area is equal to 64 what? Square inches, because we were told inches. Area is always square. So when you're doing these problems for your homework, please be careful that you use the right units. If your area, you want to use square. If it's perimeter, you have no squares on them. Okay, this is not the only way these problems can be done. There's going to be more than one way, so it's just what way you see first to do it is fine. Just check your answer in the back. Make sure you're getting the right answer. Okay, theorem 8.3.1 says the area A of a regular polygon. Okay, that's really important. This will only work if we have a regular polygon whose apothem has length A and perimeter P is given by this formula. It's very easy to use. Okay, so let's try the first problem. It says find the area of a square with apothem A equals 8.2 and P equals 65.6. Well, is a square a regular polygon? It is. Remember, regular polygon means it's equal angular and equal lateral. So that is true for this. So we're going to say A equals 1/2 AP. And we're just going to go ahead and plug in. We have all the information. We have A is 8.2, and I'm going to put the units in this time. I'm going to remember. And the P is 65.6. So when we do that, we can get out our calculators again, and we're going to say it's equal to 8. Well, we can first say, if you want, 1/2, 1 divided by 2, and then say times 8.2 times 65.6, and that gives us 268.96. Oops, I forgot the units on this second one. It was feet again. Okay, so we get feet squared here. Feet times feet, feet squared. It's an area. We want to make sure we have square units. Okay, that's the answer to that one. The next problem says, find the area of a square whose apothem measures 5 centimeters. So let's go ahead and draw a picture. Nice big square. Okay. All right, so right here is the center. Now let's talk about the apothem. The apothem is going to be from the center. It has a P in it, so it's drawn perpendicularly to the other side. So let's do this. And we know that this is 5 centimeters. Okay, well, if that's 5 centimeters, the apothem going here has to be the same thing. They're both apothems, so that would be 5 centimeters as well. Remember, we're trying to find area. So to find area, we can use any formula we want. Here, I think it's going to be easiest to use base times height. Okay, so what do we get here? Well, we know that this side here is going to be 10, okay, 10 centimeters. And what about this one? Well, it's a square, so all sides are the same, 10 centimeters. So the area is equal to 10 centimeters. The base, the height is 10 centimeters, so we get 100 centimeters squared. Now you could do this using the other formula, A and P, and you'd come up with the exact same answer. Okay, one last problem here for section 8.3. Find the area of an equilateral triangle with radius of length 4. So let's draw a nice big equilateral triangle. Probably should have used a ruler there. Okay, there's our equal. Remember, equilateral means all sides are the same. And we want the radius to be length 4. So we go to the center of the circle, and the radius now is not the one that's dropped down perpendicularly, but the one that goes out this way. Okay, so I think I'm going to use the ruler to get that going right. Okay, so we know that that is 4. Okay, all right, so we are trying to find the area, which means we have a choice of the different formulas we can use. We can use A equals 1/2 AP, or we can use A equals 1/2 B times H, either one. But no matter which one we use, we need some information that we don't have. If we use AP, we need A, okay? And if we use B times H, we're going to need this piece to come up with H. So no matter what, we've got to get this piece right here, this apothem. So let's think about what's going on. We know that this radius bisects this angle, okay? We know that positively. That's what's a fact. And do we know the measure of each one of these angles? Well, it's an equilateral triangle. So that means it's equal angular as well. So this whole angle has to measure 60, 60, 60, each one of them, which means that this one here has to be 30. Okay, if it's bisected, it has to be 30. Let's go ahead and drop down. Okay, like that. All right, so now what do we have here? We have a triangle, a 30, 60, 90 triangle. That's going to help us to get the other sides. We know that this side is 4. That's the hypotenuse. So if you remember, in a 30, 60, 90 triangle, this is taking us back, we know that the hypotenuse is equal to 2a, where a is the side here. And this is a square root 3. Remember these formulas? This is the side, the hypotenuse is 2a, the side across from 30 degrees is a, and the side across from 60 degrees is a square root 3. So hypotenuse we know to be 4. So what does that mean a is going to be? That means that a is going to be 2. All right, so we just found out that a is 2. And then we also need this piece down here, okay? So that's piece, the medium side, is equal to a square root 3 or 2 square root 3, okay? So this piece here, let's do this in red. We'll say this piece here is equal to 2 square root 3, and this piece here is equal to 2, okay? So this is very helpful because now once we know this, we have the apothem. So let's go ahead and use the formula area equals 1/2 AP. So we can say 1/2, the A, which happens to also be the apothem. This does not stand for A in the 30, 60, 90 triangle. It stands for apothem. Happens to be the same thing here. It's a 2. Then the perimeter means we need to add these sides. So if this is 2 square root of 3, then remember, this here bisects the side to which it's drawn. So this also has to be 2 square root 3. All right? So what is the whole thing then? The whole thing has to be 4 of them. We have 4 of them. So that's that side, but then it has to be this side. It's equilateral, so it has to be this side, and it has to be this side. Okay, so when we plug into the formula, the perimeter here would be 4 square root 3 plus 4 square root 3 plus 4 square root 3. Okay, so when we multiply, we're going to have 1/2 times 2 times, we're going to count these up. We have 4 of them, another 4 and another 4. Well, altogether that's going to be 12. 4 plus 4 is 8, plus 4 more is 12 square root 3. Okay, let's figure this out. 1/2 times 2, those just cancel out. Okay, those cancel out. And you're just left with 12 square root 3. Now I left the units out, but this is area. So what are we going to have? Inches squared. And that's our final answer. Again, this can be done different ways, so as long as you get the right answer, you're probably okay. That concludes this page.